Assalamu alaikum class. My name is Malia Khalid and the topic of my presentation is symmetry element. Aslam- What is symmetry? Symmetry is when a shape looks identical to its original shape after being flipped or turned. Then it is called symmetry. Symmetry is associated with the beauties and examples of symmetry are just like diamonds, flowers, butterflies, snails, shells, and leaves. These are all beautiful and have a symmetry in nature. What we have already discussed that there are five types of symmetry elements uh, as we already discussed in the previous lectures, and that is center of symmetry or inversion center. Second one is rotational axis or proper rotation. Third one identity operation, and the fourth one is improper rotation and mirror plane on the plane of the symmetry. These are the five types of the symmetry elements, but here we discuss only the one type, which is center of symmetry or the inversion center. In inversion equation, each point moves through a common central point to the opposite position and at the equidistance point. We in the inversion operation, the symmetry element is the point, sometimes difficult to see and sometimes not present when you think you see it. Here we take the example of ethane. We know that ethane molecules in a staggered configuration has an inversion center, while the methane do not have the inversion, because we know that if in the molecule a straight line is drawn from each atom through the center of the molecule, and then it is produced at an equal distance on the other side of the center, then we can say that it has an inversion center. So in the case of methane, we do not have an inversion center. And in this slide, we see that tetrahedral triangles and the pentagon do not have an inversion center, while the squares, rectangles, parallelograms, rectangular solids, octahedral, and the snowflakes all have an inversion center. In inversion equation, which of the following molecules have an inversion center? Here are five types of molecules, and we decide which molecules have an inversion center and which molecules do not have. First, we took the example of water molecules. We know that if the molecules have an inversion center, then we need to travel the equidistance and the opposite direction of that molecules. In case of water molecules, if we draw a dot or a point at the center points, we know that there is no hydrogen atom opposite to the first hydrogen atom, so the water molecule do not have an inversion center. Then we move forward to B molecules. B molecules, benzene molecules have an center of inversion, because if we need to travel from the middle to this side and subsequently moved on opposite direction, we know that there is an on other side of the molecule, so the benzene molecules have an inversion center. Then C molecules, cyclopentane. In cyclopentane, we didn't find any kind of atom on the opposite and the equidistance position, so cyclopentane do not have an inversion center. And in D molecules, we found the same thing that we found in B molecule, just as in benzene. So the D molecules have a center of inversion. And then the last molecules have a tetrahedral geometry, and in tetrahedral geometry there is no center of inversion. Which of the following molecules Only B and D molecules have an inversion center, while rest of the molecules do not have center of inversion. An inversion center may be two kinds. First of all, in the space in the center of the molecules, and second one at a single atom in the center of the molecules, as we discussed in D molecules. If it is in the space, then all the atom must be present in an even numbers, and if it is an atom, then the type of atom only must be present in an odd number. And we can say that these are the kind of basic rules to find the inversion center, and these rules are two. And first rule is that if it is present in a space in the molecule, then all the atom must be present in an even number. And if it is a kind of atom, then the type of atom must be present in an odd number. And using this consideration, there are some molecules which would decide that they have inversion center or not. We can say that AB4 type molecules have an center inversion center, while the AB3 type of the molecule do not have a center of inversion. Only B and D molecules have an inversion center. Na3, CH4, C2H2, C2H4, SOCl2, SO2Cl2. Which molecules have an inversion center? We have already discussed that AB4 type molecules have an inversion center, while the AB3 type of molecule do not have center of inversion. Here CH4, C2H2, C2H4, SO2Cl2 fulfill their rules, have no atom present in an odd number, or have only such atom. These four molecules have an inversion center, while the rest of the molecules do not have center of inversion. Na3, here are some molecules, four type of molecules, and we decide which molecules have an inversion center. We have already known that methane do not have an inversion center, while the ethane molecules have an center of inversion. In these four type of molecules, only the type of molecules have an inversion centers. Both ethane and the ethyne molecules have an inversion center, while the rest of the two molecules do not have, because both of them lack similar atom at the equidistant position from one atom. Here are some. Here some are the three-dimensional structure of molecules, four type of molecules. The first molecule is AB4 type molecules, and it is the square planar. It has an inversion center. Second one is ethane molecules, and it also have an inversion center. Third one is trans dibromoethane, and the fourth one is 1,4-dibromobenzene. These four type of molecules have center of inversion, because in these molecules each point move through a common central point to the opposite and equidistant position. So these four type of molecules also have an inversion center. Improper rotation. Rotation about 360 by n axis, followed by the reflection through a plane perpendicular to the axis of rotation. We can, and it is denoted by Sn. We can say that improper rotation actually a rotation then reflection. And in improper rotation operation, we should to rotate the molecule first and then reflect. the result would be improper rotation operation. Here we took the example of triangular molecules. If we apply the C3 rotation, C3 means 360 by 3 and it is equal to 120. If we rotate these molecules by 120 angle, it would equal to this. And then we have already discussed that improper rotation is first rotation, then reflection, then the arrow will go to downward, and it after applying S3 operation. If we apply further S3, then the structure will go on this type, and if we apply the S3 thrice time, then the arrow will go downward, and the result would be this type of structure. Improper. And if we apply the further operations on these molecules, and we rotate or apply the operation as S3 4 time, S3 5 time, and then S3 6 time. If we and then this type of structure will be obtained, and if we apply S3 6 time, then it would be equal to identity, because for an odd molecules, and the result will be equal to identity, because we rotated through two whole circles and then reflected an even number of atoms. If we rotated the two whole circles and then reflected an even number of the atoms, then the result would be equal to identity. And these, if we apply the improper rotation operation on the triangular molecule, the result would be this. And if we in the above example, the molecule is first rotated and then reflected. We have already discussed that improper rotation operation. It is actually the rotation and then reflection. And we can say that the order of reflection vary from molecule to molecules. And first example that we have already taken, the triangular molecules. In that molecules, we rotated the molecules at 120 degree, and after rotation we apply the reflection. If again it molecules then if we again rotate the molecules and then reflect it the sixth time, then the result would be equal to identity. So the improper rotation operation is actually the first rotation and then reflection. In the above example, symmetry element and symmetry operation. The terms symmetry element and the symmetry operation should not be confused with each other, because we know that the symmetry element is an axis or a plane or a point about which we apply the symmetry operation. And the symmetry operation is what? The symmetric properties of an object or a molecules are described in terms of symmetry operations, and symmetry operation can be performed on a molecules. However, we have discussed the 5 type of symmetry element. The first one is identity, and identity doing nothing. Second one is proper rotation axis or axis of symmetry, and it is denoted by Cn, and rotation about an axis through some angles. Third one is mirror plane or plane of symmetry, and it is denoted by sigma, and reflection about the plane operation, symmetry operation. Symmetry element, the next one is inversion center or the center of symmetry, and it is denoted by small I. And inversion operation, इस पे जो हम अप्लाई करते हैं वो होता है inversion is a reflection about a plane. Last one is improper rotation axis or rotation reflection axis, and it is denoted by Sn, and it is actually the rotation about an axis through some angle followed by the reflection in a plane perpendicular to the rotation axis. We know that improper rotation operation is actually a rotation then followed by reflection. And these are the 5 types of symmetry elements and their operation. Symmetry element and how to find the symmetry element in a molecule. How to find the symmetry element. Here are the example of water molecules, and we find the symmetry element present in the water molecule. The first is identity. We know that if the molecule possess or not possess any other type of symmetry operations or the symmetry element, then they they must have identity, because identity is actually doing nothing. So the first symmetric element is identity. And now move to the next one, which is proper rotation axis or axis of rotation. Axis of rotation is what? It is actually the axis which we can rotate the molecule and found indistinguishable shape from the parent molecules. So if any axis of rotation or proper rotation axis is present in these molecules or not, yeah, C2 is present. And C2, if we rotate the water molecules at 180 degree, then it can require a indistinguishable shape from the parent molecules, and the hydrogen atom will go to the other side and with upward arrow. So in water molecules only, the proper rotation on the Cn is only C2. C3, C4 or any other proper rotation do not exist, do not found in the water molecules. So we have only C2 symmetry element in the proper rotation. Now we move to the plane of symmetry. If the water molecules have a plane of symmetry or not, yeah, it have a plane of symmetry, because we have already discussed that there are 3 types of plane of symmetry: sigma h, sigma v and sigma d. Sigma h is actually the horizontal perpendicular to the axis, and sigma v vertical, sigma d is dihedral. Now the question is, which type of sigma or plane of symmetry is present in water molecules? If we cut the water molecules from the middle, then we obtained the equal result, and the water molecule is cut into 2 halves. The first half contains one hydrogen atom and the other half contains the other hydrogen atom. So in water molecules, the plane of symmetry which is present is sigma v1 and sigma v2. So the symmetry element which is present in the water molecules are actually, the first one is identity, second one is C2 axis of rotation, and the third one is plane of symmetry which is sigma v1 and sigma v2. And identity is found in every molecules, because identity actually doing nothing. The molecules which possesses or not possesses the other symmetry operations are the other symmetry elements, but it exists the identity. So the water molecules have four symmetry elements, which is first one is identity, second one is Ca2, third one sigma V1, and fourth one is sigma V2. How to find the symmetry element? The first symmetry element, which is identity, and is found in every molecules because it's doing nothing actually. The second symmetry element is the axis of rotation C2 depicted by the water molecules. When the water molecule rotated is 1 degree 80 degree centigrades and it require indistinguishable shape from the parent one. Similarly, the plane of mirror sigma is exhibited by the water molecules and it is sigma V1 and sigma V2. So this is actually about the symmetry elements in the water molecules. Thank you.